Hello, I'm Peter Ross and welcome to the Power Saving Centre. We're at 133 Musgrove Street, North Rockhampton in Queensland. Our whole objective is to try and save you, as the house owner, energy on your power bills. And one of the highest energy users in a home is an electric hot water system. So today, I'm just going to go over a couple of options on how to combat that. Well, we've just covered what happens with a collector and when that hot water heats up and how it rises to the collector. Now, there's two systems, one with the tank above it, so the hot water will rise from the collector into the tank above it. So that's easy, that's a thermosiphon system. But another very popular product, and this is a Chromagen 300 litre with a Black Max panel. It's one of the products that it is the product that we promote. It's a very, very efficient system. What happens is when that hot water rises up to the top of the collector, it can't get back down again because thermosiphoning means that the hot water will rise to the top of that collector and it can't get down because it wants to go up. So what happens is that they've got a sensor lead that's got a little plug in it and it sits in the top of this collector. Now from there, what happens is I'll go over here and I'll explain how it works. There's your panel's heated up and your tank is down below. So how does that hot water get from here down to here when it's lighter? It has that sensor lead. Now that sensor lead, it comes down here and it connects into a little brain on the side of the pump. It's a Grundfos pump as well, mind you, a very, very good quality pump. And there's a little sensor in the pump that also goes down into the bottom of the tank. Now the tank temperature is going to be always the coldest. So what happens is when the collector gets 7 degrees hotter in a variance from the bottom tank temperature, so say if it was 30 degrees down the bottom and the collector, sun shines on here, it heats it up to 37 degrees, the pump through the sensors say, righto, let's turn on, and it pumps the water from the bottom of the tank, which is the coldest, up very gradually, goes into the collector, passes the water through the collector so it absorbs the heat from the sun, and then it comes back down as hotter water and then it lays in the top of the tank. As it continues to do that during the day, that hot water will continue to go all the way down. Now even it will keep pumping around until the bottom tank temperature through this sensor picks up that it's 76 degrees and then the tank will turn off. If you draw hot water out of it and use some cold water, the cold water will be picked up by that sensor and then it will just start pumping again. And at night time, when this is 4 degrees colder than the bottom tank temperature, it will pump around. When the sun goes down, it turns off. Now this is the tank here. This is the pump, so it's a very neat looking system. You have your cold pipe that sucks from the bottom of the tank, comes through here, and then this goes up to the bottom of the collector. And then the hot pipe, which in this case would be on this side, it would come down and then the hot water would enter into here. Now there's also a tube that's in here that is tilted upwards. Even though hot water will rise, it stops it from going through the cold water directly in front of it. So the tube positions the hot water more directly up in the top of the tank. And then it just keeps it keeps pumping around the system. That's how the tank gets hot. Now, we've got a hot tank of water. Well, how do we get the water out? It's basically exactly the same as an electric hot water system from a principle then. What happens is in your conventional electric hot water tank at home, so forget about the solar at the moment, this is your standard electric hot water system. You have hot water that comes out to feed the house, and how that hot water comes out is through mains pressure. The cold water is pushing in the bottom of the tank and it fills up the bottom of the tank, and it's virtually pushing the hot water out into your shower or your laundry or kitchen. Now, there's an electric element in the bottom of your tank that's connected to power. So if you drain out your hot water, say you wash a sink of dishes, cold water enters in, and what it does, it comes in the bottom of the tank and there's a thermostat in the bottom of the tank and it just reheats the water again, just automatically cuts in. So it doesn't take very long at all for you to turn on that hot tap and for this electric element to be fired up. So to try and alleviate that, what Chromagen have done is you've got a hot pipe that comes out of the top. They bend this hot pipe to the very top of the tank so there's no wasted water above that hot pipe. When the cold water comes in, they put a baffle system in there to slow the flow of that water down. So it's the same pressure, but the flow of the water doesn't squirt in like a garden hose in a bucket of water. It doesn't mix the water up. When this fills up, and again, I will grab something. Oops. Grab one of my business cards here. Now, when you're drawing out hot water, this will start filling up full of cold water. So, in this system, it would fire up the power straight away. With a Chromogen system, it has to get a long way to the top of the tank before the thermostat, which goes down inside the tank from the top, it picks up that the hot water is starting to get cold, and then the element fires up there. So what happens is before that tank runs out of hot water, the thermostat picks it up and it just recovers it with an electric element. But you have all this grace of all the solar hot water that's basically there, free from the sun, for you to be able to utilise. If you have any more questions about these systems, because you can get really involved in it, but to answer any more questions that you'd really like to know, if you just go to powersavingcentre.com and you can ask for Pete or ask for anyone in the office, and we'll be able to answer any of your questions, or come into the office at 133 Musgrave Street. We've got all these systems here and I can run over the workings of it with you. Thank you very much.